We're going to talk about Taylor polynomials in chapter 11. And so I just want to start out with an exploration, and I can put the link to Desmos in our Blackboard shell so that you can go over this as well. But there are a lot of different scenarios, whether it's computer science or engineering, where it's easier to work with a polynomial as opposed to a transcendental function. So our transcendental functions are like the exponential, the logarithms, trigonometric functions. So they don't play as nicely with some of the algorithms that we use in differentiation, differential equations, or the sciences. So what we do is we look for a way to approximate a value that might be coming from a transcendental function with polynomials. And so I want to just explore the exponential function and show you what I mean. So we're going to be looking at the exponential function around this point 0, 1. So if we first look at just y equals 1, well, that definitely would be a good way to approximate the value of that point, because on that function, we also have the point 0, 1. But if you get very far away from that point, then you're really a far distance away from the exponential function. So we look to see if maybe there's a better curve. So if I look at the line y equal 1 plus x, now I can get a little bit further away from that point, and I'm starting to follow the curve. But notice what happens here. Now I follow the curve for even longer. In this polynomial, I'm following it even longer. Can you see how, if I try to blow this up some, how I'm following it for even longer? And now if I use this polynomial, now I'm following it even longer. So the question becomes, is there a way to represent a lot of these transcendental functions with a polynomial function? Because it lends itself to the different ideas we've been talking about in calculus.